Okay, so we're going to build our transistor on-off switch to turn a motor on and off. And here's the circuit that we'll be working with. We're going to be using tip 31C NPN transistor. That's what this one looks like. And the thing to keep in mind here is the pinout on this. When you have the tab here in the back, this tab is a heat sink, but when you have that in the back so that the transistor is sticking up, the pins are base, collector, and the emitter. Base, collector, and the emitter. And so what this circuit is going to do is we're going to be taking the input to the base resistor, and we're going to be making that high or low. And when that is high, it's going to turn on the transistor. And we've chosen this 100 ohm resistor to provide enough base current to drive the transistor into saturation given the collector current that we expect. And that's described in the accompanying analysis document. So 6 volts, the transistor is on. VCE is going to be set at 0.0, and all the rest of our voltage will be dropped across the motor. The motor will run. Then when we take the input here and we ground that so that we have no base current, the transistor will be off and the motor will be off. So it's simple on and off, and we'll be controlling that over here. Okay, so let's get going. Here are all the parts. I've got a breadboard. I've got my tip 31C transistor, motor, battery. I'm going to have to use the alligator clips to connect the circuit to the leads of the motor, 100 ohm resistor, and then a collection of wires. Okay, so I'll just start. I'm going to put the transistor into the breadboard, and you have to kind of, the pins are a little bit thick, so you have to kind of force it in there. But there it is. Now to just start wiring that up, so what I want to do is into the base, I want a 100 ohm resistor. And then I'm going to have that either be going to 6 volts or to ground. And so I'm going to use this green wire here. And I'll either be able to move it up here to the plus 6 volt rail to turn the transistor on, or down here to ground to shut the transistor off. All right. I need to ground the emitter. So base, collector, emitter. The motor is going to be connected between the collector of the transmitter and the 6 volt rail. So I'm going to get one lead on the motor connected to a red alligator clip, and that's going to go to the 6 volt rail. I like to use red and orange wires when I'm connecting something directly to one of the power rails, so I'll be using this red wire here. Okay, and then the other terminal of the motor is going to be connected to the collector of the transistor. So I'm going to need to put a little wire in there, and I'm going to use a blue one because that's the negative polarity of the motor. Okay, so that's connected. Now I have to supply the power. And go ahead and put the 6 volts on there. Ground down there. Now the motor is actually running right now. I don't have the input. I have the input neither high nor low, so it's an undetermined state. Let me ground it. And it should be off right now. So something's wrong with the circuit. Let me try to debug this. When the, let's see, the input goes to 100 ohms, and then it's going to go to the base of the transistor. I was taking my output, I was taking the output for the motor from the emitter. I had the motor connected 6 volts and then down to the emitter. So I actually had the motor connected, you know, it was like connecting the motor directly across the battery. So I had the motor connected to the wrong pin. I need to connect the motor here to the collector. Okay, now what I want to see is that the motor will turn on. Okay, it turns on when I connect this input, this control line to high, and it's off when I connect the control line to low. Now what we're seeing is that when the control line is just floating, the motor is still off. The transistor is still off in this case because I don't have any applied voltage or current going into the motor. But it's better practice to either deliberately make this high or low. Now we'll be using this circuit quite a bit later on when we need to turn a motor on and off using the output of an op-amp or the output of a computer pin. So that's the purpose of this circuit, and that's how it's done.